questions, a lot of people have talked.
No questions on the homework? Everybody's good? It's too easy, or you haven't started them?
Well, it's like they're.
I remember what it's like to be in college. You're not going to offend me. Haven't started. It's all right.
You know when
Okay.
you spread the 400 pounds over 100 G's, right?
Yeah.
That's badass.
Yeah.
Is that the same on those? Dude, I gotta check that out.
Yes. Yep. Yep. Do you want to look at another one of those?
Yes.
Yeah.
Okay.
If John has a question, we all.
Okay, so the question is kind of making sure that we've got a solid understanding of uniformly distributed loads in simple beams. Okay? So we'll make our span 12 foot. Yeah. So let's consider 12-foot span. We'll drop 800 pounds 2 foot from R1, and then we'll have 1,600 pounds distributed over 8 feet. Okay, going from R2 back to 4 feet from R1. So how would you go about solving that? What's the first step that you need to do?
Get a pencil.
Okay, that's fine. Writing utensil. It's good to make sure that we've got those.
First thing you're gonna do is write your forces sting, right?
Yep, we want to check our static equilibrium, right? So, X forces, Y forces, and make sure that our rotation's equal to 0, right? And hopefully we're firmly established in the fact that we're ignoring friction, wind, snow. We're not driving things on this, right? So we don't have any horizontal loading. What's going on in the vertical direction?
Negative 800. Oh.
Negative 800, yep.
Negative 1,600.
And negative 1,600. What else then do you have to have?
Plus R1 plus R2.
R1 and R2, right? Okay. So R1 and R2 have to sum to what? 2,400. What do you do for your moments, for your rotation?
You're gonna go.
You want to do R1 or R2?
Whichever one you want.
Let's do our.
Yeah, do R1. Okay. So for our moments about R1 to equal 0, what has to be the case? What's going to try and rotate R1?
800 pounds at 2 feet.
Yep. It's going to be positive or negative rotation?
Positive.
It's going to be positive rotation, right? Just doing that clockwise thing. Okay. What else?
You can put the 1,600 as a point load in the middle of that 8 feet.
Okay. Everybody follow why Hunter did that? Remember that for your uniformly distributed loads, the property is to put them at that midpoint. Okay? How far away is that?
10 feet.
8 feet.
8 feet or 10 feet?
8 feet.
2 plus 4.
8 feet, right? Because if we drop this at the middle, this is going to be 4 feet, 6 feet, 8 feet. Okay? Good. It's all right. This is, I mean, this specific type of setup, that's why I drew this way. These specific types of loading sequences is mostly where we get tripped up on these problems. Okay? So 1,600 pounds times 8 feet. Also going to be clockwise, right? It's also going to try and spin this thing out this way. Okay? Anything else?
R2 at
Our other reaction, right?
12 feet.
That'll be negative, right? Because it's going to try and spin things backwards. Okay, so, oops. 12 R2 pound-feet has to equal the sum of 1,600 and 12,800, right? So make that 13, so 14,400. Somebody should check that.
And then that's 14.
Yeah, let's just make sure that we get confirmation on that.
That's 12.8
12,800?
and then 16.
Okay, so yeah, it should still be 14,400, right?
14.4.
Okay. So divide both sides by 12. Well, divide both sides by 12 feet. Right? Keep our units correct. Makes R2 what? 1,200? Right? 1,200? Huh. So what's R1?
1,200.
1,200. Okay? So, that's all fine and good, but all we've done so far is prove that this thing is going to stay in place. Okay? Now we have to know what type of shear is being exerted on the beam itself. Okay?
Just the drawing.
Yep. So then just redraw your beam. R1 is over here. R2 is over here. Okay? The way that we go about shear is we march, and I've always done it left to right. That's how my brain works. Okay? If that works for you, certainly feel free to do that. If you want to, you can also do shear from right to left. There's nothing wrong with that. All that's going to happen is the drawing that I make up here, it'll be the exact same, it's just going to be flipped, right? Okay? So we'll denote that up is positive. So think about what happens to your beam. We get just to the right of R1. Okay, so we're not taking into account anything else that the beam is experiencing. What's trying to shear that beam?
1,200 up.
The 1,200 pounds from the reaction, right? Okay, now let's go 1 foot further. What's trying to shear?
Just still the 12.
Still just the 1,200, right? Okay. What about when we get to 2 feet? And let's say we're just past 2 feet, right? Oh, careful. We have 800 negative, but we still have the 1,200 positive also, right? So we have 1,200 pushing up on the beam. We have 800 pushing down on the beam. Okay, so the net is that you've got 400 pounds pushing up on the beam. Okay, because that's a point load, it picks it up instantaneously. Okay? Now what happens over the next 2 feet? It stays at that 400, right? Because we're not adding any loading. Then what do we do? How much does it go down?
1,200, I guess. It'll be negative 1,200.
It's going to go down all the way? Oh, I see what you're saying. Where is it going to go? Where does it reach 1,200?
All the way to the end.
At R2, right? Okay. How do you want to join these?
Assisted guided line.
Yep. Okay. So yeah, the key to remember, your point loads, sorry, I'll take this out so that could likely cause confusion here. Your point loads are going to cause instantaneous drops. Okay? Uniformly distributed loads are going to provide these sloped curves. Okay? So we need to determine a couple things still. What's our maximum shear?
1,200.
1,200 pounds, right? And remember that that's occurring at 2 places, right? We've got maximum here, we've got maximum here. Where does our shear equal 0?
8.
I didn't draw it very well. What?
8 from R2. 8 feet.
8 feet from R2? Is it 8 feet from R2?
I can't less than that. 7 feet.
It'd be 400 at 6 feet, right? Sorry, 400 at 4 feet. Maybe this will help. Although, it looks like my scale isn't very good. What's the slope of this line? That's not correct. It should be a numerical value, right?
It's negative 200.
Negative 200 pounds per foot, okay? So if at 4 feet we're at 400 pounds, how many feet is it going to take us to drop 400 pounds? 2 feet, right? So
6 feet.
we have scale issues there, right? But that's what happens when I'm drawing freehand up on a board. So at 6 feet, our shear is going to equal 0. Remember what that means is if this is our beam, right, and here's my reactions, or at my thumbs, and I'm pushing in on this thing, I'm not getting any bending at that reaction where I'm trying to shear it, right? Where's the maximum bending occurring? Right in the middle, right? As I try to shear the thing from the reaction, is there any shearing at the top? It's just bending, right? So that's why determining that shear of 0 is going to be very important for us. The next set of problems that we'll look at will add a bending diagram. And your maximum bending is always going to occur where your shear equals 0. Okay, sorry, where your shear equals 0 at non-reaction points. Okay? Questions? Everybody's good to go on shear? You want to start looking at bending? Or did you want to look at another problem like this?
Do one more.
Do one more? Okay. What do you want to have for loading conditions?
Did we discuss if there's 3 nodes?
What's that?
3 nodes?
What do you mean 3 nodes?
Like 3 loads?
3 loads, I see what you're saying. Okay. 3-point loads?
Sure.
Go on. Cut. Sorry, we'll change that first one to 300. We'll change that one to 400. So if that's 14, 2, that looks like 4. That's probably 3. What do we got left? 6, 9, 5. Looks like a decent scale. Okay. Okay, so what do we do first?
Set up your equilibrium.
Equilibrium, right? We know x is going to equal 0. No, this marker is not going to be equilibrium. So, what's acting in the y direction? 300 pounds, positive or negative?
Negative.
Okay, what else?
600.
R1 and R2 have to balance that, right? So it's 1300. Go about R1 or do you want to go about R2? R1, okay. So, what's causing rotation? Everything up above, right? Are they going to be rotating positive in a clockwise manner or negative, counterclockwise? They're going to be going positive, right? Okay, so how far away are they? 300 pounds is 3 feet. Anything else? We need R2, right? R2 is 14 feet away. Is it positive or negative?
Negative.
1 second, I just want to make sure that junk showing up. That's not too bad. Let me switch to this one and see if it does. Okay, so 14 R2 pound-feet equals 48 and 48 and 9. It's 10,500. Somebody check that.
No, I get it.
It's good? Okay. So R2 equals, that can't come out to a nice number, can it?
750.
750? That's not too bad. Okay. So if R2 is 750, what's R1 going to be? R1 will be 550. Yep. Plug it in up here. Okay. Everybody good? Okay. So let's step left to right. What happens when you get just to the right of R1?
Pushing up 550.
550, yep. What happens when we get a foot away? Any changes? No new forces, right? We don't have anything uniformly distributed, nothing being applied constantly. So we're going to march across until we get to 3 feet away. Then what happens?
Go down 300.
Drop 300 pounds. Good. Then what?
Over 5 feet up.
March along to 8 feet. Then what do? We're going to drop 600 pounds. So 350 pounds. Okay, then what do?
Move along to
Head across for 4 feet. What do you want me to do?
It drops again. To 750.
Good. What's your Vmax? 750 pounds. Where does your shear equal 0? 8 feet. Good. Yeah, so you're 3 feet here and you're 5 feet here, okay? So if you wanted perfectly acceptable for you to reference from R2, you would just put in 6 feet from R2, okay? It's the same answer, providing the same information, okay? Just a different reference point. O'clock. We'll probably wait on bending in the event that you have questions on the homework for Tuesday. Okay? So, what I want us to talk about, I had mentioned it briefly a couple weeks ago. The next lab that we're going to do, and for those of you in the online course, I'll give you a separate assignment where it's more kind of a paper-based on functionality of recycled materials. I want you to come up with something that we can test that's a recycled material, okay? And so what I want you to do, and I'll type something up for you. I'm teaching this online construction contracts course. I got to get, some of you are in it. I got to get that back on track today. You'll see something posted in greater detail for this lab tomorrow. I'll get it written up for you. The idea behind it is find something, and maybe it's on a construction site that you work on, Maybe it's just something you're interested in. Maybe it's something that you're going out and doing research on. So what I'm going to do is, a couple weeks ago I bought a bunch of equipment for the lab. It came on a pallet, and that pallet was held together by these plastic bands. Okay, so probably very similar to if you work on a job site where you receive pallets of things on a project site, you probably dump away pounds of this stuff on a monthly basis, okay? And what I'm gonna do is, I'm gonna take an epoxy. It's gonna be a general construction epoxy, something that we would find on any project site that we would use. And I'm gonna take, I don't know, 10, 15 of these layers and epoxy them together. Okay? And then when we go into lab, I'll do a pull test on them. And so I'll keep some of these so we can pull test an individual one, and then we can check and see my composite material, how well does it do in that pull test? Do we see an increase in the tensile strength? Does it fail in the material itself? Does it fail in the bond to the epoxy? Things of that nature, okay? So I don't want to limit you in kind of what you think about and what you could do. Another thing that I thought about that someone could do, maybe on your job site, it's coming time to put in the windows. And you get the shipment of windows, and you open up a section of them, and there's a bunch of busted up windows. Okay, so could we do something with that glass? Could we, and not saying go out to a job site that you're on and break a bunch of windows, okay? Hey, my teacher at school said that I should do this so I can use it. If it's something that you're interested in, let me know, and we can talk and figure out how to get you some recycled glass, okay? But maybe you want to look at recycled glass in concrete, okay, as something that can be used in an aggregate. So we can take some time next Thursday in lab. You can bring in your materials. If it's something where you need to make a little bit of concrete, we can use the mixer to make concrete. If you need access to an epoxy or a glue, something to glue stuff together. Okay, so, but I want you to take a week to think about what it is that you could use. And then on Tuesday when we get back together, we can talk about it and see what it is that we would need to do to make it happen, okay? So does that make sense at the onset? So, and then we'll probably do, oh shoot, that's gonna push us right up against spring break. We'll have to test them the following Tuesday. So if you're gonna make something out of concrete, it's gonna be 5 days old when we test it, not 7 days, okay? So I gotta give you a midterm exam on this stuff. Maybe something came in some sort of metal container that's going to get tossed. We'd take that metal container. The idea is just, what is it on our sites that are going in and generating a waste stream?
It can be repurposed.
Could we repurpose it somehow on the project? And I was talking about it with the architects, and they're doing it in their class, and the limitation that they provide is it has to be an exterior finish material. Well, for construction management students, I don't think that we have to hold ourselves to that constraint, right? Because we deal with all aspects of the built environment, okay? So maybe you're looking at something that could be used as a patch material, whether it's you're looking at gluing together sawdust that you could do to patch over holes in sheathing in residential construction, right? And fiberboard or an oriented, your own oriented strand board, something like that. So does that make sense? And I'll write up a couple things in the example, or in that example, in the write-up that I post online for you. So that'll hopefully provide a little bit more direction. Yes, Hunter?
Kind of question about the homework.
Yeah.
Just about this notation, when it says like 750 pound per foot, is that like saying that each foot has 750, or the whole thing is 750?
Yeah, okay. So the question is, and forgive me if I get the dimensions wrong. I think, is it 14 feet?
14 feet.
Okay. So the homework assignment has this, 750 pounds per foot, okay, over 14 foot. So when I put mine up there, I had 1,600 pounds and then 8-foot span. So you can think of this is that if you divided this up into 14 1-foot sections, you would have 14 applications of 750 pounds. Okay, so your total load is going to be 750 pounds per foot times 14 foot. Okay? Because then your feet cancel, left with pounds, which is what we like to see for total load.
Sounds good.
Yep. Good question. I mean, there's a number of ways to think about it, right? In actuality, what it is 17,000, right? 17,000 pounds, and it's just distributed over the entire span. Now, maybe what that is, maybe it's a steel beam, and it's a steel beam that weighs 750 pounds per foot, okay? So maybe it's the depth of the concrete deck that we're putting over the thing gives it a weight of 750 pounds when we think about the depth of the span itself, okay? But good question. Other questions you have?
No.
Okay. I think we'll call it there then. I want to make sure that you get a chance to work on the shear problems before we start jumping into bending, okay? Because bending, we make another leap that is a little bit more challenging than the shear.
So the terminology quiz has a question about bending. It says at what point does the maximum bending occur?
That's what this is.
Okay.
Yep.
Like it doesn't really add, I don't know if this is what that answer is. I'm not sure which answer would be that. Want to be at when V equals 0.
Yep. So out of these statements, where is the shear going to equal 0?
I would guess the midpoint, but I don't know.